What's up? What's up? What's up? It's your boy, the network. And today's topic is Objective 3.8, Configure and Verify VRF Lite. VRF stands for Virtual Routing and Forwarding. Actually, it has many names, but we're going to refer to it as Virtual Routing and Forwarding. This is a topic in the CCNP route exam, exam code 300-101, version 2.0. Let's take a look at the exam blueprint to see where we came from and where we are headed. That's a mouthful. All right, this is implementing Cisco IP routing, exam code 300-101, version 2.0. It is the January 31st, 2019. Make sure you are studying for the correct material. Again, this is for version 2.0. If you happen to stumble upon this video 10 years from now, know that this was for version 2.0. If it's still up, I may update this, or I may be studying for something else. I'm going too far here. We just wrapped up troubleshooting passive interfaces. Today we're going to be doing configuring and verifying VRF Lite, which means, yes, today is hands-on, and we doing it in GNS3. Notice in the past couple of videos, we've been trying to stray away from Packet Tracer because a lot of these features are not in Packet Tracer, so we definitely had to graduate to GNS3. After that, we're going to be moving on to configuring and verifying filtering with any protocol. It's going to be a tricky one as well. These are the meat and potatoes of the route exam because these are routing, not basics, but these are principles, like real principles of routing. So we are in the midst of it right now. We are in the trenches. Okay, so VRF Lite. VRF, basically, that stands for Virtual Routing and Forwarding. Before we talk about what VRF Lite is, we need to talk about what VRF is. VRF is basically, okay, you know what a VM is, right? A virtual machine. A virtual machine is like a fake machine, right? Or a fake computer that you put inside a real physical computer. So you can have a computer within a computer, right? So, and you can do multiple computers within one physical computer, right? These virtual machines, they're called virtual machines, and they're inside of a physical computer, right? Take this same concept with routers. We have a physical router, and we create virtual routers within this physical router, right? So it's the same thing as virtual machines, but it's a virtual router. So we got these virtual routers inside of a physical router. All right, it's kind of the same concept as VLANs, but on a layer 3 scale. VLANs will be layer 2, and VRFs are layer 3 sense, if that makes any sense. I hope that makes sense for y'all. Let's go ahead and look at the slides for the official definition. Before we do that, notice over here on this slide right here, I got a picture of, I don't know if you're familiar with hip hop, but this dude, his name is MF Doom. He's an underground rapper. He has a real cult following. Like many rappers, he has multiple aliases. He's known as, his real name is like Daniel or David Dumile, something like that. He's also known as King Dumile. He's also known as King Ghidra. He's also known as Doom, MF Doom. He got a whole bunch of aliases, right? Well, the same thing with VRF. VRF is also known as multi-VRF, CE, which stands for Customer Edge, multi-VRF Customer Edge Device, VPN routing forwarding, because VRFs are used used with VPN. Sometimes they call it VPN routing and forwarding. We're just going to refer to it as virtual routing and forwarding. We're going to be configuring VRF Lite, which is basically VRF without MPLS. If you know what MPLS is, that's multi-protocol label switching. That's basically you tagging your traffic on the wide area network, and then you taking off the encapsulation, you de-encapsulating it and sending it off to another network. But that's another topic. Let's go ahead and move on. In IP-based computer networks, virtual routing and forwarding is a technology that allows multiple instances of a routing table to coexist within the same router at the same time. So if you look at this picture at the bottom, this was a perfect, I got this from Kevin Wallace. Shout out to Kevin Wallace for this little image right here. You got the physical router here, and you have these like virtual routers inside the physical router. So it's kind of like fake little routers that you create, and they each have what's special about this is they each have their own routing tables, right? So you do show IP route on each one of these fake routers that we're gonna be creating. I'm gonna show y'all this in GNS3. It's pretty neat, man. It's pretty cool. Because routing instances are independent, the same or overlapping IP addresses can be used without conflicting each other. That's the other neat thing about it. If you're on a physical router and you create an interface and you give it the IP address 198.168.1.5, right? You can't create another interface on the same router and do 1.6 or 1.7 because those IP addresses are going to be overlapping. Well, If you create virtual routers, it's like having another router, a separate router, and you can create this IP address or interface that overlaps an interface that's on this physical router. It's like you making a whole nother router. This picture right here just says it all right here. When I saw this, it became clear to me, this topic right here. Network functionality is improved because network paths can be segmented without requiring multiple routers. So again, it's like you getting the bang for your buck if you have a router that can create virtual routers. You look at this picture right here, it's like you having 4 routers all together. Now, a lot of times ISPs use this solution because they can create separate instances, these virtual routers, for their customers, because for security reasons, we don't want these routers to know about each other's routes. So we're keeping them separate, right? But however, you can leak these routes. However, that's another topic. That's going to be beyond the scope of this topic right here. Here's another picture that kind of cleared it up for me as well. You see these, like you look at this circle right here, right? We got this physical router and we got these virtual routers in different colors. We have the red router that's going to be handling resources for our resources. The blue router handles the resources for our partners. Green handles the contractors. And this yellow router handles guests and NAC quarantine, right? Same thing with this. We have basically this physical router right here with these virtual routers right here. These are instances. That's what we call them. And I'm going to show you how to create those in GNS3. Also, notice this says IPVPN. Normally, in a regular VRF solution that an internet service provider does, is these are essentially VPNs. That's why they sometimes call it VPN routing and forwarding. So VRF Lite, which is a flavor of VRF, is a feature that enables service providers to support 2 or more VPNs, which is basically what we did here. So we got like 4 VPNs here, 4 VPNs here, and 4 separate VPNs here. And the service providers, this is a provider's edge. That's why it says PE right there. They've got separate VPNs for each of them, right? Where IP addresses can be overlapped among the VPNs. VRF Lite uses input interfaces to distinguish routes for different VPNs and forms virtual packet forwarding tables by associating 1 or more layer 3 interfaces with each VRF. So, step 1, you create the virtual routing and forwarding instance. It's real simple. You create the VRF by doing IP VRF, and then you just create a name. And in this topology we're going to create, we're going to have like basically one company, and we're going to have like a headquarters router. I'll show you all the topology, but this is a simple command that we use to create the instance. It's like you creating a fake router, if that makes any sense. Oh, look at that. Cisco Live is going live on YouTube right now. Wish I was there. Step 2, assign an interface or sub-interface to the VRF instance. We're going to create sub-interfaces. We're going to have a regular interface, and below that, we're going to have several sub-interfaces. There's a couple ways you can implement this solution. However, I'm going to show y'all one way, and maybe I may do another video to show you another way to create a VRF solution. It is important to note that if an IP address already exists on the interface, the following command will remove the IP address. And step 3, configure a static route, which we all already know how to do that. If you don't know how to configure a static route, go look at my CCNP playlist, or you ain't got time for that. It's just basically IP route. In this case, it's VRF, the name of the VRF, and then the network mask interface or outgoing nest, the outgoing interface or the next hop. However, we're not going to configure a static route. We're going to be associating a routing process with each VRF. In this case, we're going to use OSPF so we're not going to be configuring a static route. We're going to use OSPF. And these are some verification commands that we can use if we want to pause it, freeze frame it. We're going to be using some of these commands as we are building this VRF solution that I'm going to show y'all. So this video may go over our 30-minute limit. However, I'm going to try to edit it and try to go as fast as I can to get through this. We're going to go hands-on with GNS3. Let's go ahead and fire that bad boy up. All right, so here's our topology that we going to create. Shout out to Kevin Wallace for this topology and this idea. However, this is what we're going to do when we set it up. So we got our headquarters right here, right? This is our headquarters router. We have this layer 3 switch, and we are going to create several sub interfaces, as you can see right here, FA0.0.2/0.2.3 and .4, right? And then this is going to be trunking. This is why we said it's almost like a router on a stick, because we're going to have a trunk, a .1Q trunk right here. Right? This little port right here is going to be trunking, and then we're going to create these separate VLANs kind of to communicate with these other physical routers. So these are physical routers right here. We're going to have several instances. We're going to have 3 instances of VRFs that we're going to create on the headquarters router. This is one way we could do to separate our traffic. This is why we're doing not an ISP solution. Maybe I may do another video where it's kind of like we're doing an ISP and we separating our customers. In this case, we just got one company that's separating different parts of its network. So we got its voice router here, its data router here, and its video router right here. And then we got the local area networks. Don't worry about that. So let's go ahead and go into the headquarters router, console in that bad boy, and create the VRF instances. You remember how to do that? Pause it and think about it. All right, we back. Remember, we already in config mode, so it's IP VRF, right? And then the name of the VRF. So in this case, we're going to create a VRF for the voice. We're going to start with the voice. We're going to create a VPN for this network, a VPN for the middle network, and a VPN for the bottom network, right? We're going to start with voice now. IP VRF. The name of it, we're going to just do voice. This is case sensitive. Make sure you put the correct voice. Put the correct name and watch the case. I'll put a question mark there. Just make sure I know. Let's go ahead and create all 3 instances, actually. IP VRF data and video, right? Data, we're going to do these lowercase. IP VRF I can't type today. VRF tonight. It's like 3 in the morning. Video. So we created our 3 instances. Notice we are in VRF config mode, right? Let's do a show IP VRF. And you can see these are the VRFs we created, right? Those are just basically like fake routers we created in this real router. We got the data, the voice, and the video router. However, we don't have any interfaces that are associated with them. These are RD. Since we are using OSPF, we don't really need to create RD. That stands for route distinguishers. And I believe since we are using OSPF to share our routes, we don't need to do that. I'll put it in the notes below to make sure. All right, so let's go ahead and create our sub interfaces, which are these guys right here, those 3. We need to go to the physical interface first. So IP FA, and make sure that's on, right? Interface FA 0/0, no shut. I believe it's already up. Nope, it's down, so now it's up. Let's go ahead and create our sub interfaces. Interface FA 0/0.2, and then we're going to give it the IP address right there, 192.0.2.1, and then the subnet mask 255.255.255/30, so it's .252, right? Right here, notice it says here, configuring IP routing on a LAN subinterface is only allowed if it's already configured as part of 802.1Q or ISL VLAN, which we are going to do that. Let's make sure they are routable. Let's go ahead and create the forwarding instance, right? That was the next step. Let's make sure we created the VRF instance. We are gonna assign the interface now, right? IP VRF forwarding and then the name. So in this case right here, IP VRF. We created the sub interface and the IP. Now we do IP VRF forwarding. This sub interface is gonna be forwarding for the first one, which was voice. Let's do uppercase so you can see what happens. Voice. VRF voice is not configured. That's why I said it's case sensitive. Make sure you are writing the correct case when you do this. VOICE. And notice it took it that time, right? So now we are forwarding forward. Let's make sure we are encapsulating .1Q, because remember, this is going to be a trunk. We may have to go on this switch. I may fast forward through that part too, but we may have to go on the switch to make sure that interface is trunking. Encapsulation .1Q. This is going to be, we're going to tag it the VLAN 2, right? Remember that top one is VLAN 2. Let's go ahead and see what we got so far. Actually, let's go ahead and do the same thing with the next 2 interfaces, right? We're gonna do IP VRF forwarding and then the name of it, right? So in this case, let's do the next subinterface, interface FA00.3. We're gonna give it the IP address 198.51.100.1, 255.255.255.252. Since it's a /30, we'll give us the same thing right here. We're gonna do encapsulation.1. We're gonna put this one in VLAN 3. And then the most important part, which is the IP VRF, we're saying it's forwarding, right? IP VRF forwarding for the second physical router, which will be data. Y'all see that? Data. I'm going to show y'all something else. We're going to do the last subinterface, interface FA0/0.4, right? We're going to give it the IP address 203.0.113.1, 255.255.255.252. We're going to make sure we are encapsulating .1Q. This is going to be on VLAN 2, 3, 4. Put that one on VLAN 4. IP VRF. Y'all with me so far, right? IP VRF forwarding. This is going to be forwarding for the last one, which was the video, right? Watch this if we don't put it in the correct one. Let's say Voodoo. It's going to say Voodoo is not configured. That VRF is not configured. So you make sure it is the correct case sensitive. Remember, it's case sensitive. So the name of it was voice, lowercase. And notice it took it that time. Let's go ahead and exit out of that. Let's run a couple show commands to see what we got so far. Do show IP VRF. You can see, okay, so the video is not, y'all see, this is why we need to do show commands here. So we got the data to the correct interface. We got voice on the 2, and we did video. It's not in that interface. So we need to make sure, what did we do wrong here? We said it's going to be 4, right? VLAN 4. So video is wrong. We need to make sure that the video is in that interface. It's forwarding for that interface, right? Let's make sure. Interface FA00.4. For some reason, it's over here. So let's do this. That's probably because we did this right here. Let's make sure we take that out. No IP this. Right? No IP this. So let's go back into interface FA00.4. No that. It is not in it, so let's make sure we go to the video interface. Let's go back into interface FA0/0.4 and make sure we are IP VRF forwarding for the video. Right? Exit. Let's do a show IP VRF, and now it's correct. Y'all see that? It's a good reason. It's a good thing we did our show command here. Let's make good practice of that. Each step along the way, we are running some show commands. Let's also we need to run OSPF on these bad boys here. Let's go back into interface FA00.2. We're gonna start off with that one. Router. Actually, I take that back. Router, OSPF, we're going to do the first one. We're going to do OSPF 2, right? And then we're going to do network process failed, cannot start. What we doing here? What we doing wrong here? This is what we need to do. This is the tricky part about this. When you are using any kind of routing protocols for these virtual routers, you don't just create the routing process. You need to define the VRF that it's going to be sharing routes for. So in this case, we doing the first router, right? This guy, the first VPN for the voice. We need to do router, OSPF. We're gonna create a process. We're gonna create one, right? Now look at these options we have right here. We got VRF after you do that. So normally, you would just do router OSPF and then go into config mode. That's what we did wrong. After that, you got to do VRF and then name which VRF this routing protocol is going to be for. So in this case, it's going to be the voice, already exists and is attached to default IP routing table. So let's go ahead and no router OSPF 2 to remove that. Router OSPF VRF voice. Oh, my bad. 2 VRF voice. Now we're in router config mode here. For some reason it failed, but let's go ahead and network. Allocate router ID. I don't know why it failed to do that. We may have to look into that, but let's go ahead and network. We are just gonna run OSPF on all our interfaces in this case here, and do area. We're gonna put in area 0, right? Let's do a show IP protocols to make sure. We can't do that because we're doing it on a physical router if you do that. So let's do show IP. Hold on, let's get out of this. Show IP protocols VRF. Don't be afraid to use the question mark, y'all. VRF, the voice one, right? And notice we are routing for that network, right? On OSPF 2. Router ID is quad 0 for some reason. Maybe we got to give it an IP address. This the headquarters router. That's probably why the router ID is that. We haven't given any. We haven't given an IP address. All right, so I believe that's correct so far. Let's go ahead and do some routing processes. Let's run OSPF on the other routers here, right? Configure terminal. Let's do the second router, which is data IP VRF. The name of it, I believe, which is data, and then router. No, we need to do router OSPF. We're gonna do OSPF 4. No, 2, 3. We'll do router OSPF 3 for this one, and then VRF, and then what else we need here? I believe that's it, right? Oh, the name of the OSPF, name of the VRF, which is data, and then now that we've done that, OSPF process failed again. Network and quad 0. Remember, when we do this, you just saying run OSPF on all these interfaces. 255.255.255.255 area 0, and we're gonna do the same thing on the last router, which would be, I believe, the video router. Configure terminal router OSPF 4 VRF, and it's the video. We're gonna do network. See, it failed again. We don't care. We're just gonna move on. 255.255.255 area 0. Okay, so let's go ahead and let's take a look at our routing table so far for these virtual routers that we created on the headquarters router. Remember, we created 3 virtual routers in this, guys. Let's do a show IP route VRF. Let's take a look at the first one, which was the data, I believe. That might have been the second one. Voice. We're going to be looking at the voice routing table. And notice IP route. We don't have any connected interfaces though. This is the problem. We got an issue here. We don't have any connect. We should have some kind of connected interfaces on here. Let's do show IP VRF interfaces. Those are correct, but we need, I believe we need the IP addresses assigned to those guys, and that's what's wrong. That's what we're doing wrong here. Which I believe, let's do a show run to see what we got so far. Make sure these are correct. Now, where do we put those IP addresses? I don't know what happened to those IP addresses. That's what's wrong here. Let's go back into that interface and put the IP address in there. That's probably what we did wrong here. Configure terminal interface, right? And then we're gonna give him the IP address of subinterface needs to be IP address 192.0.2.1 255.255.252. Let's do a show run to make sure it was in there. And there it go. For some reason, the IP addresses didn't go in there. So now, if we do show IP interface FA 0/ show IP VRF interfaces, and there it goes. See, now the IP for some reason we didn't put the IP addresses there, so we need to do the same thing for this guy. Let's make sure. Okay, let's go into interface FA 0/0.3. IP address is 198.51.100.1 255.255.252. And let's do the same thing for interface FA 0/4. And then IP address is 203.0.113.1 255.255.255. I'm sorry for becoming bland, y'all, but right now it's 4 in the morning and it's time for me to go to bed. However, I want to try to knock this out. Let's go ahead and verify our configuration so far. Do show IP VRF interfaces. And there it go. Now we got IP addresses for those. So maybe we could check the routing table. If y'all remember how to get rid of the logging console, I believe it's no logging console. I don't remember. That's annoying. Let's try that. Let's try that real quick. No logging. Well, maybe we got to go in the config mode. No logging console. I don't remember. I don't think that's it either, y'all. Yeah, that's it. I had to remember what that was. So let's do, we need to see the routing table for our VRFs. Show IP route, right? Then you do the VRF and then the VRF name. So in this case, we're going to do the first one, which is voice. And now you can see he has a directly connected interface 0/0.2, right? Boy, this is taking longer than expected, y'all. We may have to cut a lot of this BS out. I don't know what happened here for some reason. Okay, so now we've got our interfaces. We got them trunking over here. Let's go ahead and move on to, we need to make sure we are running OSPF correctly on this bad boy. I believe we are. Yeah. See, these are OSPF processes right here. Those are correct. Those need to be correct. And if you look at our routing table, we don't have any OSPF routes just yet. However, we're going to have an OSPF route going here, learning through some through here and some through there. We need to work on the trunk. This is kind of off topic here, but we're going to go ahead and do that. I may figure out a way to fast forward this. If not, y'all may have to sit through this part too. All right, so we're going to go to the switch 1 console into that bad boy. Make sure that FA00 is trunking. Configure terminal interface FA 0/0. Y'all remember how to do that? Switch port trunk. Switch port. My bad. What else we missing? Switch port trunk encapsulation. .1Q. That's it. And then switch port, we're going to double check that. We're going to make that solid. Switch port mode trunk. Now, that port is trunking, as you can see. So this port is now trunking all the VLANs, right? So now we need to create some VLANs and make them separate, right? So we're going to create a VLAN here, create a VLAN there, and create a VLAN there. Again, this is a little off topic. These are layer 2 commands, but y'all can sit through this if y'all want to. Let's see. VLAN, get out of this. VLAN database. I think we need to go in the, let's do no logging console on that bad boy because that's annoying. Configure terminal no logging console. Go back into that bad boy and do an VLAN database. And we're going to do VLAN 2 for the first one. We're going to name that voice. Voice. Right? We're going to do VLAN 3 for the next one. So we're going to put this one in VLAN 3. Y'all with me so far? This is VLAN 2. VLAN 3. That's going to be VLAN 4. So VLAN 3, the name of that is going to be what? Data? How are we going to remember this? Talk, data, and video, right? Talk, data, video. So voice, data, and the last one is going to be VLAN 4 video. So we talk, and then we got the information, then we go on TV. If that makes any sense. So now we created our VLANs. Let's go ahead and take a look what we got so far. Show VLAN. I believe it's switch. This is I mean, I remember this is not a real switch. This is GNS3. So you got to do show VLAN switch. I believe it is switch. Yeah. So now we created our VLANs, and there they go. Right, VLAN 2, 3, and 4. So let's go ahead and put those ports in those VLANs, right? Again, this is a little off topic. This is layer 2 stuff, but y'all can sit through this if y'all want to. VLAN 2, FA0. So this is going to be VLAN, again, VLAN 1, 2, and 3. I'm sorry, VLAN 2, 3, and 4. So FA01. Interface. I may skip this. I may cut this part out, y'all, because this is a little off topic again. We need to go to interface FA0/1, switch port mode. My bad. Access, switch port access. Wow, look at that. This is the time for me to get up when I used to, lab in the morning. It's 4 in the morning right now, and I'm sitting here. We need to shut this bad boy off. That might go off again. Switch port access. Put this one in VLAN 2. Right. Now we're going to move on to the next interface. Interface FA0/2. We're going to put that. We're going to put this one in switch port mode. Access. Switch port access. VLAN. Put that in VLAN 3. And the next one we're going to do interface FA0/3. Y'all with me so far, right? We're putting this in VLAN 2, 3, and 4, right? FA03 is going to be in what? Switch port mode access, switch port access, VLAN 4, right? So now we created our 3 virtual instances in here, virtual routing instances in here. We created the trunk to forward that traffic separately though, on separate VLANs, and we created VLANs on the layer 3 switch. So we got a VLAN and put the ports on each VLAN, respective VLAN. Now what we need to do is create. I already put the IP addressing, so we can skip that part. I already saved the configs for the IP addresses for these routers. All we got to do now is create some put OSPF on these routes for them to share their local networks, right? So we're gonna create a routing process, OSPF on those routing process on these routers, right? The physical routers. These are physical routers, and we're gonna run OSPF on them, right? So that way you can share the local routes. On the voice router, we are going to configure terminal router OSPF. We're gonna put it on OSPF 2 just to try to stay consistent. And we're gonna share the 10 network. Actually, here's what we're gonna do. We're gonna run OSPF on both of these. Just run OSPF everywhere. The way we do that is what? A network quad 0 255.255.255.255. That means we don't care. Just run OSPF everywhere. Put it in area 0, and we should share network. We've made a neighbor. Notice he's made a neighbor, right? Let's go back to him. He says process 2 neighbor. His neighbor is 192.0.2.1. Who is that? That's this guy right here. Right. Let's go back to the headquarters router and see what happened here. It did not say. We don't have a login message there, but he did say that he made a neighbor. Let's show IP route VRF voice and see what happened there. Notice we have an OSPF route learned. That's the 10.110 network. Where is that? That's over here. So this physical, there's a virtual router in here that has a VPN connection to this router and knows about the 10 network. Can he ping it? Can he ping the 10.111 IP address, which is this interface here? You can guess he can, but we don't just do when you're working with VRF, so you don't just do ping and then the IP address. You got to do this is the tricky part right here. Ping. Let's see. VRF, notice right here, select VPN routing instance. So you got to pick which virtual router you're pinging from. So ping VRF, right? And then the name of the VRF, which in this case is going to be our voice router, or our fake router that's in here that we named voice. Then we're going to pick the IP address. We can pick whatever we want. In this case, we're just going to do the IP address of this physical router's interface right here. So we got a fake router in here that's going to ping the physical interface of that router, of this physical router, which is 10.111, right? Let's go ahead and ping that, which is 10.111. You see you got a reply. If y'all want, we could do the same thing for these two. If not, you can cut it off right here. But basically, we're going to do the same thing. We're going to do the same thing. We're going to run OSPF on this guy, run OSPF on this guy, and see if we can get the route for these two local area networks, and then ping them. So let's go to the data router. Where's data? Right here. Configure terminal router OSPF. We're going to do OSPF 4. No, we're going to do OSPF 3 on that one. And then network, we're going to run OSPF everywhere here. 255. This is like, hey, OSPF, where my neighbors at? Where my neighbors at? Where my neighbors at? That's what we're doing when we do this command right here. We're not selecting specific interfaces that we advertise in OSPF from. We advertise in OSPF everywhere. 255.255, area 0. He should make a neighbor. He's saying hello, hello. Anybody running OSPF here? And it's taking a while. Something wrong here, y'all. We did something wrong. Let's check. Did we, on the data router, right? We running OSPF on him. OSPF 3, network. Let's check his IP addressing scheme here. Do show. There's a little troubleshooting bonus for y'all. Do show IP interface brief. We got FA10, right? That's wrong. Yeah, that's right. 10 is 172.16.11, right? That's correct. And then 11 needs to be 198 address, right? That's correct too. Let's make sure that the subnet mask was wrong. Because I remember I was experimenting with this and I had the wrong subnet mask. Do show IP, do show interface FA1/0. That should be a /24 address. That's correct. The other one should also be /24. So let's make sure we go into FA, that guy right there. Now, exit. Let's get exit out of that. Do show interface. That is also a /24, 198.51, 100.2. That's correct. Let's make sure let's make sure we got the correct VLAN on the switch. FA02 needs to be in VLAN 3, correct? Is that correct? Let's make sure. FA02 needs to be in VLAN 3. Do show VLAN switch FA02 needs to be in VLAN 3. That's correct. And that's the data VLAN. That's correct too. Let's do show. We know we trunking because we was able to get the first one correct. Do show interfaces trunk. And FA00 is trunking. Let's make sure that let's go in the headquarters router. I may or may not take this part out, but we are approaching 1 hour on this video here, y'all. Interface. Let's see what we need to check here. Let's go to the headquarters router. So IP VRF interfaces, right? The 0.3 needs to be 198 address, right? 198.51.100.1. That's correct. Let's make sure that it's the /30 address, which I believe it is. Show interfaces. Show interface FA0/0.3. Is it /30 address? That's correct. What we need to do here. Anybody see what's wrong here? 198.51.100.1. Is it forwarding? That's the question. FA00.3. All right. Let's check. 00.3. Right. .1Q is VLAN 3. The VRF forwarding data is correct. IP address is 198.51.100. That's correct. The other one is in VLAN 4. .4 forwarding video. That's correct. Let's check our OSPF. VRF voice data, right? RSPF, this is OSPF 3, and video is OSPF 4. So what are we doing wrong, y'all? Let's go back to we said we was gonna do data, right? That's the one we need to do. We put OSPF on there. OSPF 3. Headquarters says OSPF 3. Let's go back to data. Is it up? Yeah, it's up. That's up. How about the headquarters? Let's go to the switch. Are these interfaces up? Show IP interface brief. Yeah, nothing's down. Nothing is down. Those are all up. Let's see if we can go to the let's see if we can go to the video router and see if we can fix that bad boy. We'll worry about him later. Configure terminal interface. I'm sorry. We need to do router OSPF 4. We're going to do network quad 0 255.0. No, my bad. 255. And then, oh, we need to do the area 0. That should be it. That should be neighbors now. There you go. For some reason, we can't get the data one going. We'll figure that out in a second. Actually, I may just call it a night, y'all. We'll have to figure that out later. Once I figure it out, I'm gonna put it in the notes below. That's my contact information, y'all. If you like this video, please comment, like, subscribe to the network. I'm gonna let y'all know I know I gave y'all a cliffhanger, but I'm gonna put down what was wrong in the notes below.